In lesson 13, we take a look at the remainder theorem for the factor theorem, zeros of polynomials, and how we can graph polynomials using these zeros and the shape of a polynomial. So what is the remainder theorem? The remainder theorem allows us to find the remainder of the process of dividing a polynomial by a binomial that is linear. If we divide some polynomial p of x by a binomial x minus a, we know we will get some quotient polynomial and a remainder. Now, because the degree of the divisor is 1, the degree of the remainder is going to be less, so it's going to be a degree of 0, which means the remainder is simply going to be a constant. Okay, now we can write this division problem as p of x equal to x minus a times the quotient polynomial plus the remainder. Now, notice what happens when we plug in a for x. So if we take p of a, we get a minus a times q of a plus r, and a minus a is simply 0, so our p of a turns out to be the remainder. And that is exactly what the remainder theorem says. It says to calculate the remainder of dividing a p of x by a linear term x minus a, you simply take the number a and find the polynomial value for a. The remainder theorem says, given a polynomial p of x, if we're dividing p of x by x minus a, then the remainder is simply p of a. So let's say we've got this p of x equal to some x cubed minus, say, 2x squared plus 8x minus 5. If we're dividing this p of x by x minus 2, what we simply do is we simply put x minus 2 equal to 0, and we find an a value of 2, and the remainder is simply p of 2. So that'll be like 2 cubed minus twice the 2 squared plus 8 times 2 minus 5, and here's an 8 minus an 8, and 16 minus 5 is simply 11. So we can say that the remainder when p of x is divided by x minus 2 is simply the number 11. Now, what if the remainder is 0? For instance, if you've got p of x equal to x cubed minus 2x plus 1, and you're dividing this p of x by x minus 1, and you try to find the remainder when you divide it by x minus 1, you can simply set x minus 1 equal to 0. You get an a value of 1, and you plug the 1 into x, into p of x. For x, you get p of 1 equal to 1 cubed minus twice the 1 plus another 1. This gives us a remainder of 0. Well, a remainder of 0 means that this polynomial is actually divisible by x minus 1. And that leads us to our second theorem called the factor theorem. And the factor theorem says if p of some number equals 0, then x minus a is a factor of p of x. Let us now look at p of x equal to x cubed minus 4x squared plus x plus 6. Let us try to now show that x plus 1 is a factor of p of x. Now, if I'm trying to show that x plus 1 is a factor of p of x, I need to plug in -1 for x and show that -1 makes the p-value equal to 0. Because when I set x plus 1 equal to 0, I get an a value of -1. So when I plug in -1 for x, I get -1 cubed minus 4 times -1 squared plus -1 plus a 6, and that simply gives us 0. So when I show that p of -1 is equal to 0, I can then conclude that x minus -1 or x plus 1 is a factor of p of x. Now you might ask yourself, if x plus 1 is a factor, what are the other factors? To find the other factors, we actually need to take our p of x and divide it by x plus 1. Now we may choose to do this by synthetic division or by long division. So let's just practice long division here. So we take x cubed minus 4x squared plus x plus 6, and let's divide this by x plus 1. Now x goes into x cubed and x squared number of times. So we get x cubed plus x squared. And then we change sign and add, and we get -5x squared. And we bring the x and the 6. Then x goes into -5x squared minus 5x times. So when you multiply -5x with x plus 1, you get -5x squared minus 5x. Then you change sign and add, and you get 6x. You bring down the 6, and that simply means we multiply x plus 1 by 6, and that indeed gives us a remainder of 0. Then our remaining factor is simply x squared minus 5x plus 6, and we can factor this down further as x minus 3 and x minus 2. Okay, so we've got -1, that makes p of x 0, and then 2 and also 3. And actually, these numbers, -1, 2, and 3, are called zeros of this polynomial, or zeros of the function p of x. So what is the zero of a function? A zero of a function c if f of c equals 0. when you plug in that value, that input value, you get an output of 0. So for our polynomial, we had -1, 2, and 3 are zeros of our p of x. And these zeros actually have a y-coordinate of 0 if we're trying to graph our polynomial. So if we're trying to graph our polynomial, these would appear as x-intercepts. So we would be using these points as our x-intercepts. And because our polynomial was a cubic, now a cubic polynomial has a shape that looks like an S or a reverse S. And it's an S shape if the leading coefficient is positive. And if the leading coefficient is negative, then it's a reverse S. Our leading coefficient was 1 because we had x cubed minus 4x squared plus x plus 6. And our leading coefficient was 1, so it belonged to this particular shape. And to graph it, we can simply make it go through these x-intercepts. And in addition, we could also find the y-intercept. And we find the y-intercept by plugging in a 0 for x. So if we want to find the y-intercept, we set x equal to 0. When we do that, we get a y value of 6. So in addition, we could make the graph go through the y-intercept. So it's going to go through the x-intercepts and the y-intercept with an S shape. Let's take a look at this example. Given that p of x is minus x to the fourth plus 2x cubed plus 3x squared minus 8x plus 4, let us show that 2 and minus 2 are zeros of p of x. Now, what that means is when we plug in 2 for x, we should get a 0. So we take negative 2 to the fourth plus 2 times 2 cubed plus 3 times 2 squared minus 8 times 2 plus 4. And we want that to equal 0, which it indeed does. And then p of minus 2 is again negative 2 to the fourth plus twice the negative 2 cubed plus 3 times the negative 2 squared minus 8 times negative 2 plus 4. And this turns out to be negative 16 minus 16 plus 12 plus 16 plus 4. And that is also equal to 0. So we know, and we've just shown, that 2 and minus 2 are zeros of p of x. Okay? And then, let's say they ask us to find the other zeros of p of x. What we can say is that if 2 is a 0, then x minus 2 is a factor. And if negative 2 is a 0, then x minus 2 or x plus 2 is a factor of p of x. So combined, we can say x squared minus 4 is a factor of p of x. So we can simply take p of x and divide by x squared minus 4 to see what other factors are in p of x. And when we do that, when we do this division, we say x squared multiplied with minus x squared gives us minus x to the fourth. So we multiply the entire divisor by negative x squared, so we get negative x to the fourth plus 4x squared, and we have to line it up correctly. And then when we subtract, we change sign and add. So the x to the fourths go, and we have 2x cubed minus x squared minus 8x plus 4. Then we say 2x cubed is really x squared plus 2x times 2x. So we take 2x and multiply it with x squared minus 4. And we get 2x cubed minus 8x. And when we change sign and add, we just get minus x squared plus 4. And that's simply minus 1 times x squared minus 4. So our other factor will be negative x squared plus 2x minus 1. And if we want to factor that, we actually factor it as minus x squared minus 2x plus 1. And that stuff in the parentheses is a perfect square trinomial. So really what we got is minus x minus 1 quantity squared. So we have another 0, which is 1, and it's a double 0. We're asked to sketch the graph of p of x. These will be our x-intercepts, negative 2, 2, and 1. 1 will be a double 0. Okay, now the double 0 means the graph is going to be tangent at 1. It's not going to intersect. It's simply going to be tangent to the x-axis. And if we want to get the y-intercept, the way we get the y-intercept is by plugging in 0 for x. We get a y value of 4. So we can also use the y-intercept and have our graph go through these 4 points, these 4 intercepts. Now, when we've got a quartic function, that means of degree 4, the shape is either an M, this is if the leading coefficient is negative, or a W, and the W happens when the leading coefficient is positive. In our case, the leading coefficient is negative, so we've actually got an M shape. So we're simply going to go through these points, be tangent to the x-axis, and then go up and go through the other x-intercept. In lesson 13, we took a look at the remainder theorem of polynomials, the factor theorem, and we also defined what zeros of polynomials are and how we can graph a polynomial using its zeros and its shape. I hope this lesson has been useful, and I'll see you in the solutions to worksheet 13.